My name is Liqing Jiang. I work at NOAA's National Centers for Environmental Information through the University of Maryland. Today, I will share with you a new coastal ocean data product called Codefna. Before I start, I want to acknowledge my co-authors. This is truly a community effort, and I got lots of help from a lot of them, especially my co-investigators. I'm sure we all know the importance of data products in oceanographic research. The ocean is a global system, and observational data from different platforms often need to be QC'd and put together in order to understand regional to global processes. Then we could contribute to our society's mitigation and adaptation efforts. The GOA-ON data product has contributed to the research of global ocean carbon cycling tremendously. It contains many parameters and has coverage for the entire water column from surface to the bottom of the ocean. The only problem is that the GOA-ON is an open ocean-based product. Although there are some coverages in the coastal area, the coastal ocean has never been their focus. So the question is, should we create a similar product like the GOA-ON for the coastal ocean as well? A very important goal of the OA research is to help the fisheries and aquaculture industry to adapt to the changing water chemistry. Despite covering only 7% of the global sea surface area, the coastal ocean accounts for about 90% of the global fisheries yield. Yes, that's correct, 90%. So from an economic point of view, a GOA-ON like a discrete bottle-based product in the coastal area would be even more important. Thanks to resources from NOAA's Ocean Acidification program, we were able to make a step forward in that direction. This project is a collaboration among NCEI, PMEL, AOML, Northeast Fisheries Science Center, as well as 10 academic institutions. Considering this was a very short 2-year project, we had to make a decision about our priorities. The group decided that in the first step, we would focus ourselves on data from laboratories with a track record of producing high-quality data. Instead of trying to get all the data we could possibly find, we tried to establish the QC procedures and applications in this initial funding cycle. These are the identified QC procedures. We have 0-level QC procedures on the left side. These are the QC steps conducted by the data collecting investigators. We also have primary level QC steps in the middle. These are the steps conducted by the data product development community. Primary level QC is mainly focused on internal consistency checks within a cruise. Second level QC, on the other hand, is focused on cruise-to-cruise offsets or factor adjustments. We took our time to develop the tools and applications for our purposes. We believe this will lay the foundation for future QC efforts like this. What you are seeing is an interface to load data from Excel into our database. It can recognize any major column header conventions automatically. After making sure all these columns are identified correctly, by clicking this import data button, the program will load data into the database and do all the necessary calculations automatically. Some of the calculations like calculating depth from pressure, calculating AOU from oxygen, and also do all the calculations for the carbon system. This is the main interface of our QC tool. It is used to identify outliers. One powerful function of this tool is that you can click on any of these points, and then all the related information or the data point will show up on this right side panel. For example, its values, its station, its cast number, depth, etc. Everything will show up there. We also maintained a set of cruise flags that are applied to all the cruises we compiled. If you are interested in their definitions, please check out our paper. The product we produced has now been published at the ESSD and is called Codefna. The data are available to the public in many formats like Excel, CSV, NetCDF, and also MATLAB. This version of the Codefna has over 3,000 profiles from 61 cruises. It has good coverage for all these carbon parameters. Like for example, these are the stations with both DIC and alkalinity measurements. These are the stations with spectral photometric pH measurements. These are the stations with carbon ion measurements. This is for discrete FCO2 measurements. We also have these stations for oxygen and all these stations for nutrients as well. Not surprisingly, most of the stations have a maximum sampling depth of less than 250 meters. Only about 6% of the stations have a sampling depth so greater than 1500 meters. These stations can be used for future crossover analysis. This figure shows the seasonality of the sampling. Most of the stations were collected during summer and fall, and there is very little wintertime coverage except the Gulf of Maine area. Right now we are busy working on the climatologies and atlases for a lot of these parameters. As an example, here are the maps of aragonite saturation states. You can see the large differences from the west coast to the east coast and from the surface to all the way to 2,000 meters depth. These are the maps for pH. It is interesting to see that although pH does not show much differences in the surface, it is significantly lower in the west coast than in the east coast in the subsurface. If there is one thing I want you to take home with, it will be this slide. First, it's very important to collect a third carbon parameter for internal consistency check purposes. Spectral photometric pH measurements have become a standard measurements for many cruises. Now a lot of the labs are starting to measure carbon and ion concentration as well. Second, please also take deep water samples for crossover analysis purposes. I compared some deep water measurements from AOML and PMEL and was amazed at how good they were. I was able to use them to estimate the measurement uncertainties. Some of these measurements were over 10 years apart, but their reported DIC and TA values were nearly identical. Last but not the least, please make sure to have a sample ID column. This is extremely important for QC communication purposes. My QC programs rely on them to check what has been changed during the QC steps. Very quickly, I want to share with this audience that we have a data standard paper under review with Frontiers in Marine Science right now. Hopefully, this standard will make future QC efforts even easier. This concludes my presentation. I want to use this opportunity to thank OAP for their funding support. I thank Tim and Alexei for helping with the grading methods. I also want to thank the GOA-ON committee for giving me this opportunity to share my research with you all. Thank you.